In this video, we're mostly going to focus on reflections, rotations, and translations, and not so much dilations today, but we'll come back to those at a later time. Let's practice by using a map or a rule to transform a given point or a triangle. So take a look at this first one. It says we're translating. Remember, that means we're shifting left, right, up, or down. Okay, we're going to take this point R and move it according to this map. So it might help to write down the coordinates of point R just like we did before. Point R is at, let's see, 1, 2, 3, -3, -1. And so my translation tells me, okay, what am I going to do at X? Well, my map says I'm not going to do anything to X, so my new point is going to be at, here's my old point, -3, -1. My new point will be at, I guess -3 is the same, X doesn't change, and Y, we're adding 6 to that. So I'm going from -1, adding 6, I'm going to be at 5. So my new point, R prime, will be at -3, 5. 1, 2, 3, 4, 5, all the way up here. And that'll be R prime with a little apostrophe, the new R, R prime. Now something interesting is happening here. Did I really need to do this whole process and write all the points out? Well, what my map is telling me to do is to keep the same number for X and to increase Y by 6. On the graph, what that looks like is, starting at R, I'm not going to move in the X direction at all, keeping my X. I'm not going to move left or right, but I'm increasing Y by 6, so I'll move +6 in the Y direction. 1, 2, 3, 4, 5, 6. So all I could have done is just taken my original point, moved up 6, and gotten to R prime. The same thing is going on with number 2. I have this original triangle here, PZL, but instead of writing all the points out and doing all the calculations, I could just look at my map and realize that, hey, this is telling me to increase the X direction by 2, and to do nothing with Y, right? From the pre-image to the image, Y is not changing, but X is increasing by 2. What does it mean to increase by X by 2? Well, it means that I'm going to go, I guess, 2 units in the X direction. So starting with Z, I'll move 2 units in the X direction. L, same thing. P, same thing. So here is Z prime, here is L prime, here is P prime, and let's connect the points to make our triangle. And there's our new triangle. Pause the video here, go ahead and try and do number 3. Remember, number 3, we're going to have to go, looks like, back 5 in the X direction and down 3 in the Y direction. So pause the video now and try that one out. The answers are going to appear on the screen in 3, 2, 1. So as you can see, starting with R, I went back 5 in the X direction because my map says X minus 5, and I went down 3 in the Y direction because my map says Y minus 3, and I've gotten to R prime. Here are the other 2 points mapped. And here is the fully translated triangle. And there it is. Let's go back up to the top for a second and just write some examples of translations. Here are some examples of translations that we've seen. If you wanted to translate an image right 1 and down 4, that means that you would add 1 in the X direction, because you're going right 1, and you would subtract 4 in the Y direction because you're moving that image down 4. Similarly, if you wanted to go left 2 units, that means that you're going to go backwards, or -2 in the X direction. If you're not going to move anything up or down, then Y will stay the same. Those are some examples of translations. What about reflections? Well, number 4 asks us to reflect across the Y-axis. The most important thing to identify is the axis of symmetry. And so that is the Y-axis. So let's highlight that right now. Here's the Y-axis. Now, one of the most important things to know about reflections is that the distance from the pre-image to the axis of symmetry will be the same as the distance from the post-image, or the image from the axis of symmetry. So if this is F, and it's 2 units away from the axis of symmetry, the Y-axis, then my image, F prime, is going to also be 2 units away. I can continue to the same thing for Z, M, and Y. Okay, Z is 2 units away, so that means that Z prime will also be 2 units away. 2 right there. M, let's see, is 1, 2, 3, 4, 5. That means M prime will be 1, 2, 3, 4, 5 units away. There's M prime. And Y, since it is 5 units right here, it'll be 5 units on the other side of that axis of symmetry. let's go ahead and draw in our figure. And there's our figure right there. Looks like a trapezoid reflected across the y-axis. Number 5, reflection across y equals -1. Again, you got to start by drawing that axis of symmetry. So y equals -1, that means y equals -1. Well, here's where y equals -1, and that line is going to look like this. You know what? I think that you can reflect this triangle across that axis of symmetry and draw the image of it. Pause the video now and try and draw that reflection. The answer will be up on the screen in 3, 2, 1, and there is my image. You can double check by seeing that since C is 2 units away from the axis of symmetry, that C prime is also 2 units away. A is 1, 2, 3, 4 units away, and so A prime is also 4 units away. S is 3 units away, and S prime is also 3 units away. Number 6 is a little bit interesting. We're asked to reflect across the line y equals x, and the first thing we need to do is draw our axis of symmetry, draw that line. Now you might remember that y equals x is the same as y equals 1x plus 0. And so we can use that slope-intercept form to help us graph. Our intercept will be 0, so our y-intercept, there it is, and our slope will be 1, so over 1, up 1, over 1, up 1. There's our slope, and from there we can draw our line. Now this map is a little bit different, but it can be treated in the same way. To find where, starting with M, where M prime will be, instead of going up or sideways to get to my image, I'm going to go diagonally straight at the line of symmetry. We could say that this is perpendicular to the line of symmetry, and that's what it should be. So I went 1 square diagonally to get my line of symmetry, or in other words, I went 1 over and 1 up. So that means to get to M prime, I'm going to do the same thing, to go 1 over and 1 up, and there is M prime. Or you could say I'm going 1 diagonally. Same thing with the other letters. To get from L to L prime, let me think. I have to go 1, 2, 3 units diagonally. In other words, I'm going 3 over and 3 up. So I'll go another 1, 2, 3 diagonally to get to that L prime. Again, 3 over and 3 up if you prefer. So P, I'm going 2 and 2, or 2 diagonally. So I'll go another 2 diagonally to get to P prime. There it is, P prime. And then F, I'm going 1, 2, 3 diagonally. So I'm going to go another 1, 2, 3 to get to F prime. Let's connect those dots, F prime, L prime, M prime, P prime, and maybe erase some of those extra lines we made. That looks a little better. We can clearly see our image and our pre-image. If you're having trouble seeing that these two are reflections, it might help to tilt the picture a little bit. Notice that if we take our graph and rotate it slightly, we can clearly see that these two, our pre-image and our image, are exact reflections of each other across our line of symmetry. As we said, this transformation or this reflection was a little bit different from before because we were working with a diagonal axis of symmetry, and so we had to move diagonally across to reflect. One important thing to note though, we already said that the distance from the axis of symmetry to the image and to the pre-image has to be the same. You can see it's kind of the same there and it's the same here. But what we didn't mention was that when we take that distance, it's got to be perpendicular to the axis of symmetry. So we can't say that like this and this are the same. No, those are definitely not the same. We've got to take lines that are perpendicular to the axis of symmetry. So something like this. See how those are perpendicular? They form a 90-degree angle, and they are congruent. See how M and M prime, those form a 90-degree angle, and they are congruent. And even L, okay, L and L prime, those form a 90-degree angle, and those are also congruent. Okay, so reflections, two things, I guess, has to be the same distance from the axis of symmetry, and that line that connects those two images has to be perpendicular to the axis of symmetry itself. Let's write some of the things we've learned above. Before we leave reflection for good, there's one last thing I want to mention. Take a look at some of the coordinates that we were reflecting. Going back to number 4. The coordinate of z was 2, negative 2. The coordinate of z prime was negative 2, negative 2. It looks like we changed the sign of the x-coordinate from 2 to negative 2. If we look at the coordinate of m, M has the coordinates 5, comma 2, and the coordinates of M prime are -5, comma 2. So it looks like we're keeping the same y value, 2, and switching the x value from positive to negative. Something interesting also happens with number 6. Take a look at the coordinate of p, right? P is at the coordinate 1, comma -3, whereas p prime is at the coordinate -3, comma 1. So it looks like the x values and the y values are just being switched. 1, comma -3 changes to -3, comma 1. L has a similar thing going on. If we look at L, the coordinate of L seems to be 4, comma -2, and the coordinate of L prime looks like it's -2, comma 4. So in this case, it looks like we're switching the x and the y coordinates. We're going to see that reflections do funny things to maps. Sometimes they change values from positive to negative, like in number 4. Sometimes they swap the x and the y values, like number 6. Let's write what we've learned up above. Alright, so let's write some things under reflection. So we just noticed that reflecting something over the y-axis changes the x value to be negative. So let's write that down just here. We notice that reflecting over the line y equals x swaps the x and the y values, and we can write a map for that by writing xy goes to y comma x. We're switching the x and the y values. We also learned that the axis of symmetry is always at a 90-degree perpendicular right angle to the line that connects the image and the pre-image. Now, this may seem a little daunting right now, a lot of things to remember, but we're going to work on it more in class. The basic thing to remember is how to find a reflection. Something like number 4 and number 5 is what you want to be able to do. Number 6 we'll spend some more time on together in class. Let's talk about rotations and finish up this video. Now, the backside has 3 rotation problems. Now, these are some of the most difficult kind of transformations to do, and so we're going to do them a little bit slower, and I'm not going to go into too much of the technicalities now. We're going to do more of that in class. Instead, I'm just going to literally rotate some of these coordinate grids to give us a better sense of what a rotation is and what these will look like. The first problem asks us to rotate 90 degrees counterclockwise about the origin. First, what's the origin? The origin is the point 0, 0 in the middle of our graph, so we're going to be spinning things around that point. Next, counterclockwise. Which direction is that? Well, if you think about a clock, the way the hands of a clock move, typically they move in this direction around a clock. So counterclockwise will be in the opposite direction. So for this problem, we're going to be moving that triangle in this kind of direction around the origin, spinning it that way. And 90 degrees, well, we know what 90 degrees means. It means that this triangle right here is going to be moving 90 degrees probably up into this area. So it's going from this shape to something that's maybe going to look something like this, something like that. But let's be a little more precise and actually spin the figure. So here we go. I'm taking the figure and I'm rotating it 90 degrees counterclockwise. And it looks like I end up right about there with this new figure. So you can kind of see that when I rotate my figure, that A prime is going to be right here, that W prime is going to be right there, and Y does not move because Y is in the center of rotation. Notice that I've moved it 90 degrees counterclockwise, all of those points. So you can go ahead and draw in Y prime, W prime, and A prime, and connect those to draw your figure. Let's see, the second one asks me for a 180 degree rotation about the origin. So again, I'm going to spin around this middle point. That's my center of rotation. And it doesn't matter whether it's clockwise or counterclockwise, 180 degrees is half a turn either way. Let's go ahead and spin it. All right. And so it's 90 degrees there, and there's the full 180 degrees. And let's line this up a little better. And there it is. All right. So it looks like my new M is going to be right here, so that's M prime. My new Q is going to be here, Q prime. And my new L is going to be right here, L prime. And so you can draw that figure. And again, we did a 180 degree turn right around the origin, 180 degrees right there. Last, let's do number 3. Number 3 asks us for a rotation of 90 degrees clockwise this time. So if you think about a clock, right? Clock, the hands of a clock move in this direction right here, going around like this. Okay? So that means that this is going to have to move clockwise as well, so in this kind of direction. Let's go ahead and rotate the figure. Alright? And a nice right angle, there it is. Let's line up our figure a little better. And that is a 90-degree rotation. So it looks like H prime will be right here. We've got J prime right here, and L prime right here. Connect our vertices, our points, to get the figure. Now, let's just take a look at the coordinates for 1, 2, and 3 for a second and see what the rotations actually did to the coordinates themselves. Take something like W here. W has the coordinate 4, -3, but W prime has the coordinate 3, 4. So what happened there? Well, when we rotated 90 degrees counterclockwise, it looks like we switched the X and the Y coordinates, right? And we changed this Y coordinate to a positive X coordinate. So two things are happening. We're switching the X and the Y. For -3 goes to 3, 4. And we're changing the sign of one of them. What about if we rotate 180 degrees? Well, L was at the coordinate, let's see, 4, 5. And now L is at the coordinate -4, -5. So it looks like what's happening here is we're just taking the X and the Y's and we're making them both negative. That's interesting. So 4, 5 changes to -4, 5. And the third one, take something like point L. So point L right here is at -5, -4. And up here, point L is at what looks like to be -4, 5. So when we rotate 90 degrees clockwise, looks like we are switching the X and the Y's again, okay, and changing our original X value to be positive, kind of like we did with the first one, but in the first one we changed the Y value to be positive. So there's some strange things going on here with the maps, the algebraic maps with rotations. Let's write these things down on the front page. And here they are, right under rotations. If you rotate 90 degrees counterclockwise, like we did number 1, you're switching the X and the Y's to Y and X, and you're switching the sign of that original Y value. If you're rotating 180 degrees counterclockwise, or in any direction I suppose, you're changing the X and the Y and making them both negative, like we saw in number 2. And if you rotate 90 degrees clockwise, well, you're taking the X and the Y's, switching them to be Y and X, and changing the sign of X. Now, everything you've seen here for reflections, rotations, and translations gets a little bit complicated when it comes to the actual algebraic mapping. Save those for class. We're going to do a little more talking about those and figuring out what those mappings look like. But for now, I want you to finish up by looking at the backside. To check to make sure you've understood what we've done so far, I want you to complete 7 through 14 by yourself. The answers will not be on this video. Choose the ruler map that describes the transformation. So, I guess I'll give one to you now. Looking at something like number 7. Which one of these describes what's going on here? Well, it's definitely translation, but what kind? The black image is my starting image, my pre-image, and the blue one is where I'm ending. So let's see. To get from the black one to the blue one, I'm going down 2 in the Y direction and over 3 in the X direction. So that would be, let's see, down 2 in the Y direction, over 3 in the X direction. That looks like, A right here. That looks like A. Okay, adding 3 in the X direction, going down 2 in the Y direction. So you get one for free. After this, try doing 8, 9, 10, 11, oh, I guess just, wow, 7, 8, 9, 10, 13, and 14. What happened to 11 and 12? No one knows. But try those, and then when you come into class next time, the video check will be to put down your answers to 7, 8, 9, 10, 13, and 14 as your video check. Make sure you rewind, copy down what you need to, ask me questions, send me emails, come to me during advisory, and I'll see you next class.